So in this video, we're going to talk about the discriminant and what it is and how it helps determine what types of solutions you're going to get when you apply the quadratic formula to a quadratic equation. So the discriminant is b squared minus 4ac. It's this radicand that's under the square root in the quadratic formula. And the word discriminant comes from the fact that b squared minus 4ac, that number, discriminates, or it tells you what type of solutions you're going to get, whether they're going to be rational solutions or irrational or even complex. And here's how it works. It has to do with the sign. So if the discriminant is positive, so that means you would have a positive number under the square root in your quadratic formula, then that's the case where you're going to get either a rational or an irrational number depending on whether you have a perfect square discriminant or not. Okay? If the discriminant is 0, then you have the square root of 0. And so then you only have x equals the opposite of b over 2a as one repeated rational number solution. And then if the discriminant is negative, that means you're going to have a negative number under the square root sign, which means that you're going to have your two complex conjugates as solutions. Okay, so let's use that discriminant with these problems. So in the first problem, you've got quadratic equation. It's already in standard form, so that's important that it be in standard form before you calculate or you compute your discriminant. So let's see here. So A is 1, B is 1, and C is negative 1. Okay. And so B squared is 1 squared minus 4A times C. So that's a 1. And then here we're going to multiply this negative 4 and this negative 1 to make a plus 4. Positive 4 and 1 plus 4 is 5. So this discriminant is positive, and it's not a perfect square, right? Not a perfect square. So according to our table, okay, coming up here, positive not a perfect square means you have two different irrational solutions. So two irrational solutions. All right, let's go to number 2. Now, notice the instructions to the problem said compute the discriminant and determine the number and type of solutions. It didn't say anything about go ahead and find the solutions. So that's why we're stopping here once we said there will be two irrational solutions. Okay. In number 2, this quadratic equation is not in standard form, so we are going to rewrite it in standard form first. And remember, it's a good idea to keep your a positive, so we're going to move the 12x and the negative 4 over. Subtract 12x at 4 equals 0. So now a is 9, b is negative 12, c is 4. So discriminant is b squared minus 4ac. So negative 12 squared minus 4, and then a times c is 36. So then here we got what? 144, and then here we have 144. So our discriminant is 0. So when our discriminant is 0, then we get one repeated rational solution. And we sometimes call that a double root because it happens twice. So it's repeated. So it's double. Okay. Okay, in our next example, we once again have a quadratic equation not in standard form. So we're going to go ahead and add the 4. Okay, so now we get a is 5. Okay, notice there's no middle term, no x term. So that tells you that b is 0. And then c, the constant, is 4. Our discriminant is b squared minus 4ac. So 0 squared minus 4. And then a times c is 20. So we get 0 minus 80 or negative 80. And that means that our discriminant is a negative number. So that means we have a negative under the square root in the quadratic formula. So that's when we have those imaginary numbers. So two complex conjugate solutions. This quadratic equation has two complex conjugate solutions. Okay. All right. And then this one. Okay. Notice now here that the A is negative, right? So I'm going to actually move the 6x squared over to the right and put a 0 on the left, because we can do that, right? So positive 6x squared minus 5x minus 6. A is 6. B is negative 5. C is negative 6. The discriminant, b squared minus 4ac. Negative 5 squared minus 4, and then a times c, which is negative 36. So this is 25 plus 144, which is 169. So that's a positive discriminant and a perfect square. So that means that when we take the square root of 169, we're going to get a pretty number. We're going to get 13, which means your quadratic equation has two rational solutions, because the 169 will come out, the square root of 169 is 13, which is rational. Okay.